Hi everyone, and welcome to this Saturday session with Exam Revision. I'm Robert, and I am going to be taking you through some Leaving Cert chemistry today. In particular, we are going to look at pH calculations and complete some exam questions in that area. So as I've said, we're going to be doing pH calculations, so that is our learning intention for today, to complete exam questions on pH calculations, while I'll also give you a quick summary on how to approach the calculations and any formulae that you may need. And of course, as always, you can find Exam Revision on our social media platforms. So we're on Twitter, Instagram, TikTok, Facebook, and of course YouTube. Or you can find us on examrevision.ie, and that's where you'll find the full Leaving Cert Chemistry course done out in completion in video format with H1 standard notes, self-correcting quizzes, and past exam questions and solutions, all there for you. So check that out. But as we said, we're here to look at pH calculations and some exam questions, so let's get moving. So the big question on everyone's lips is probably, where does pH and the calculations appear? And pH and calculations can appear in several areas of the paper, but it is important to be aware that pH calculations will appear with concepts centered around acids and bases. So for example, in the past, we've seen conjugate acid-base pairs, we've seen definitions around conjugate acid-base pairs. What is a strong acid, what is a strong base, weak acid, weak base, etc. So they all appear with pH calculations, along with titration curves, which we won't be covering today. We're just covering the pH calculations. So if you're planning on answering this topic, it is very important that you have a good awareness of your theory of acids and bases along with pH titration curves. So where does the pH calculations appear? So you could get a very short pH calculation in question 4 if it's a very simple pH calculation. But it is more likely to appear as a 25 mark question in either question 10 or question 11. Now, if it appears here in questions 10 or 11 as a 25 marker, the bulk of the marks will probably be going for a calculation. So somewhere between 12 to 15 marks out of the 25 will go for the calculation. The other areas then will either be a pH titration curve or just some simple acid-base definitions to bulk up that part of the question. Alternatively, it could appear as a complete long question in section B in questions 8 or 9. So they're the options that it can appear in, and it's very important, as I said, you know your acid-base content as well when you are doing your pH calculations. So before we can do some exam questions, it's good to maybe just run through some of the key things that you would need to do some pH calculations. So the first thing is to look at the ionic product of water. And what we need to know is that water can react with itself, and this is called the self-ionization of water, where water can form the hydronium ion and a hydroxide ion. And this is an equilibrium equation, and that gives us basically our Kc that we have here, because equilibrium, first of all, is a constant. So the equilibrium constant by the concentration of the water is the same as the Kw, which is the ionic product of water. So this is just how we write it. And the ionic product of water is the concentration of the H plus ion multiplied by the concentration of the OH minus ion, and both of these are in moles per litre. And this is useful if a Kc calculation was to come up. One final thing that you need to be aware of is noted here that the concentration of the H plus ion in moles per litre times the concentration of the OH minus ion in moles per litre is 1 by 10 to the power of minus 14. So that would mean that the concentration of the H plus ion is equal to 1.0 by 10 to the power of minus 7, and that is the same as the concentration of the OH minus ion in moles per litre. Now if you're looking for a more detailed description of this ionic product of water, you can find that in the pH videos on examrevision.ie. So moving on, we would look at what is pH. That's important to know what pH is before you can do any pH calculations. So pH is the negative logarithm to the base 10 of the hydrogen ion concentration in moles per litre. And we can see here that it has a formula. pH equals minus log to the base 10 of the H plus ion, where the square brackets indicates the concentration in moles per litre. So this is your definition, and if they asked you to define pH in an exam, I would be giving this word definition, and I'd just be writing the formula in brackets in order to guarantee your full marks. Now, when it comes to pH, we also have something called pOH, And when you add your pH and your pOH, that equals 214. Now, pOH is needed when we are calculating the pH of a base, and we will see that in some of the problems that we have later on in the video. So, when it comes to calculations for acids, we can have strong acids or we can have weak acids. Strong acids are fairly straightforward. You just fill into the pH equals minus log to the base 10 of the H plus ion concentration. This H plus ion concentration, you should be able to figure it out in the question from your balanced equation. So it's important that you are able to work with ratios when you're doing this question, and that links back to stoichiometry, which is covered in another Saturday session that we have here on exam revision. And secondly, you also need to be able to figure out molarity. So molarity is moles per litre. So for example, if you're given grams per centimetre cubed, then you can get it into moles per litre. They're the main things that would be on a strong acid calculation. A weak acid calculation requires a little bit more work. So for a weak acid calculation, you must use the acid dissociation constant here, which is Ka, and you must find the molarity of the acid Ma, which is the molarity in moles per litre. But once you can figure out this H plus ion concentration by working out the molarity and filling in the acid dissociation constant, it's fairly straightforward. Then you just fill in again into pH equals minus log to the base 10 of the H plus ion concentration. So it is just the weak acid calculations, there is just this extra step here involving the molarity and the acid dissociation constant instead of using the ratios that you would have had for strong acids. So when it comes to your base calculations, it's fairly similar, except we are going to be calculating the pOH of bases when we are calculating them. And once we calculate the pOH, then we must fill that value in to find the pH into this formula. So the order that the formulas will be used for your base calculations is the pOH formula will be first, and then the pH one is second. So that's them numbered there for you. Strong base and weak base, the premise is still the exact same as your acids. So for your strong base, you need to find the concentration of your OH minus ion. You can do that by finding the ratio in your balanced equation and working with that. And then similarly for your weak base calculations, as we had with weak acids, this time you're using your base dissociation constant by the molarity of the base to find out the concentration of the OH minus ion, which you then fill into the formula we've labelled number 1 here, and your answer consequently into number 2 to figure out your pH. So they're the same concepts as we move throughout. So let's have a look now at some exam questions and we'll work through them. So this is our first exam question that we're going to look at, and this is 2016 question 10A for those of you that are following with the exam papers. So here we just want to read through the question to get an idea of what we're being asked. So the first question says to distinguish between a strong acid and a weak base. Now this is worth 6 marks here, and the key word that you're looking for is distinguish. So distinguish means to tell the difference. So you need to write your definition there for your strong acid and your weak acid in order to pick up your full marks. Part 2, then, that is your calculation question. So it says calculate the molarity of a sulfuric acid solution that has a pH of 2. So there we will be looking at our pH formula. And then it says that the acid dissociation constant of a weak monobasic acid is 1.8. Calculate the molarity of a solution of this acid that also has a pH of 2. So we're going to be working back and using our formulas to manipulate to try and calculate the molarity. Part 3 then asks you to define, so this is a definition, so to define Kw, which is the ionic product of water. So they're basically asking you there, what is the ionic product of water? And then they give you the value of it, and then they ask you to find the concentration of the hydrogen ion. So very manageable there. So let's begin and work through this question. So part 1 there, that is your definition. So I'm not going to go through those. Definitions should be known. So just a strong acid, it's a good proton donor, and a weak acid is a poor proton donor. They were worth 2 marks each. This video is mainly focusing on calculations, so I'm going to move on to part 2. Part 2, it asks us to calculate the molarity of a sulfuric acid solution that has a pH of 2. So what we're going to do here is, the first thing is we know it's pH, so we're going to write down our formula. pH equals minus log to the base 10 of your H plus ion concentration. Now, we're looking for the H plus ion concentration here because it's asking us to calculate the molarity of the sulfuric acid. So the molarity would be the concentration of the H plus ion in moles per litre. And I know that the pH is 2, so I can say 2 equals minus log to the base 10 of the H plus ion. Now, we know that to get rid of a log, we must do the anti-log. But first I'm going to change the sign. So we want to get rid of the minus that's here. So my equation will become minus 2 equals log to the base 10 of the H plus ion concentration. And as I've said, to get rid of the log, we use E, or the anti-log. So E to the power of minus 2. That's going to be equal to your H plus ion concentration. Now, what we get that to be is we get that to be 0.01. But I know that this is sulfuric acid, so it's H2SO4. So that's going to go to 2H plus and SO4 2 minus. So that would mean here that I will need to take the molarity of the H plus ion that I've gotten and divide it by 2 to give me 0.005 moles per litre. And the reason that we are dividing by 2 there, as I've mentioned earlier on in the video, this is a dibasic acid. So because it's 2H plus ions, we must divide by 2 to find the concentration of the H plus ion. Now moving on to the next part, it says the acid dissociation constant Ka for a weak monobasic acid is 1.8 by 10 to the power minus 4. Calculate the molarity of a solution of this acid that also has a pH of 2. So in this, it's important to know that we're looking at the molarity of a monobasic solution. So we're still told that the pH is equal to minus log to the base 10 of the H plus ion, because that's our formula. And we know again that that's equal to 2. And we're also told that we've the acid dissociation constant. And we're asked to calculate the molarity. Now we know the only formula that we have that has molarity is this one here, where the concentration of the H plus ion in moles per litre is equal to the Ka times the molarity of the acid. So if we're able to figure out the concentration of the H plus ion, we know the figure for Ka, we can then rearrange our equation to get the molarity of the acid. So I'm going to rearrange my first equation that I have here to get the H plus ion on its own. So that's going to give me, if I bring this down here like this, there we go. We can go log to the base 10 of the H plus ion is equal to minus 2. So that means the concentration of the H plus ion is going to be 0.01. Now, because this is a monobasic acid, it's a 1:1 ratio. So the answer will remain that the H plus ion concentration is still 0.01. So now that we have this H plus value, we can use the second formula now, which is that the concentration of the H plus ion is equal to the square root of Ka times the molarity of your acid. And I know the H plus ion concentration is 0.01, so that's equal to the square root. We know that the Ka value is 1.8 by 10 to the power of minus 4, and that's multiplied by the molarity of the acid. So now we just literally need to go and find the molarity of the acid. So we can do 0.01 to be squared. This will get rid of the square root. That's equal to 1.8 by 10 to the minus 4 times the molarity of the acid. And then we can say that the molarity of the acid is equal to 0.01 to be squared over 1.8 by 10 to the power of minus 4. And when you put that into your calculator, you will get that the molarity of the acid is equal to 0.555 moles per litre. And that is part 2 completed now of this question. So let's just assign the marks for where you would pick up in this question. So obviously we know the definitions are 6 marks. We've gone through that earlier on. We were reading the question. So if we move on to part 2, it's worth 12 marks. So you got 3 marks for figuring out that the concentration of the H plus ion was 0.01. You then got 3 marks for understanding that it was dibasic and that you had to divide by 2. Your next set of 3 marks then came from filling in to your formula here on this line, and then the last 3 marks came for your final answer. So the last part we want to do here now is we want to do part 3, and part 3 refers to the ionic product of your water. So the ionic product of water, the start it asks you for the definition, which I'm going to skip, but I am going to just write down that the ionic product of water is the concentration of the H plus by the OH minus ions. That's the formulaic definition. In an exam, that is sufficient for your definition. And then it asks you to calculate the concentration of the H plus ion. Now, from our theory, we should know that the Kw is equal to, as we've said already, the concentration of the H plus ion by the concentration of the OH minus ion. But we know that that's equal to, from the question, 9.0 by 10 to the power of minus 14. Now we know that the concentration of the H plus and the OH minus ion are equal. So H plus, the Kw can be rewritten as H plus squared, because we know, I'll just note it up here on the top, the concentration of H plus is equal to the concentration of the OH minus ion in moles per litre. So that's still equal to 9.0 by 10 to the power minus 14. So the concentration of the H plus ion will be equal to the square root of 9.0 by 10 to the power of minus 14. So that leaves me with the concentration of the H plus ion is equal to 3.0 by 10 to the power of minus 7. Then for part 3, the marks go 3 marks for your definition, and then you just got 4 marks for your final answer for this calculation. So that's one sample question on pH and the calculation. So let's try another one. So this next question we're going to look at goes all the way back to 2011, question 7. And this was a long question, a 50 marker on acids, bases and pH calculation. So there's certain parts of this that we're not going to go through. I'm specifically going to go through part D of this question because it specifically relates to the pH calculations, but we'll read through the full question anyway. So it says sulfuric acid is a strong dibasic acid. That is important that you note that. It's written in the question for a reason. So it's a dibasic acid. So your ratio there is going to be 1:2. The formula HA represents a weak monobasic acid. How do strong acids differ from weak acids in their behaviour in water according to Arrhenius and Bronsted-Lowry? So there they're looking for 4 definitions. They're looking for a strong acid in terms of Arrhenius and Bronsted-Lowry, and they're looking for a weak acid in terms of Bronsted-Lowry and Arrhenius. So because there's 4 definitions there that you would need to write down, that is 3 marks per definition. Part B then says, what is the conjugate base of sulfuric acid and the weak acid HA? Which of these conjugate bases is stronger, and explain. So that's all theory on conjugate acid-base pairs. So again, that would need to be known. And in particular there, why, which of these conjugate bases is stronger. You would need to know which is stronger and why. Part C then says, explain by giving a balanced equation for its dissociation in water that the conjugate base of sulfuric acid is an acid itself. So there they're looking for you in this question to write out a balanced equation where you have your sulfuric acid reacting with water and you can show the properties requested then. The one that we're most interested in is part D, and it's worth 20 marks, so 20 out of 50. The calculation and the content on pH was worth 40% of this paper. So it asks you to define pH, and then it asks you to calculate the pH of a 0.2 molar solution of a weak acid whose acid dissociation constant is 6.3 by 10 to the power minus 5. And then it asks you what is the concentration of a sulfuric acid solution that has the same pH. So let's dig in. We're going to specifically look at part D. So D, the first part of D here, it asks you for the definition of pH. So we know that pH is equal to minus log to the base 10 of the H plus ion concentration. And I would recommend that you do that out in words then. Underneath that pH is the minus logarithm to the base 10 of the H plus ion concentration expressed in moles per litre. The next part of the question asks you to calculate the pH of a 0.2 molar solution of a weak acid, HA, the value of whose acid dissociation constant Ka is 6.3 by 10 to the power minus 5. So we know that this is a weak acid, so we're going to be using 2 formula. We're going to have pH equals minus log to the base 10 of the H plus ion concentration, and we're also going to be using the formula that the H plus ion concentration is equal to the square root of Ka times the molarity of your acid. So let's begin. So in order to use this pH formula, we do need to find out the concentration of the H plus ion. So we're going to do number 1 first. So we know that we're looking for the concentration of the H plus ion, and we know that the acid dissociation constant from the question is 6.3 by 10 to the power minus 5, and that the molarity of your acid is 0.2. So when you pop that into your calculator, what you will get is that the H plus ion concentration is equal to 3.549 by 10 to the power of minus 3. Now that we have the H plus ion concentration, we can very simply go and find the pH. So the pH is equal to, writing it down again, minus log to the base 10 of the H plus ion concentration. So that's equal to minus log to the base 10 of the H plus ion concentration, which is 3.549 by 10 to the power of minus 3. So when you put all of that into your calculator, what you get is 2.449. So your pH is around 2.4. So that is the first part done. Then it says, what is the concentration of sulfuric acid solution that has the same pH? So if we're looking for the concentration of the solution, we're looking for the H plus ion concentration. So we know that pH is equal to minus log to the base 10 of the H plus ion concentration. And in the second part of the question, we are looking for, to get this in its own here, the H plus ion concentration. So we know, it says in the question that it has the same pH, so I can say 2.449 is equal to minus log to the base 10 of the H plus ion concentration. Now I want to get the H plus ion concentration on its own, so I'm going to change my sign first of all to 2.449 equals log to the base 10 of the H plus ion concentration. And to get rid of the log there, we get the anti-log, so we're going to have e to the minus 2.449 is equal to the concentration of the H plus ion. And the concentration of the H plus ion in moles per litre then is 1.75 by 10 to the power of minus 3. And that is your answer there. So let's assign marks for this calculation so that you know where you'll be picking up marks for. So you'll get 6 marks for your definition there for writing out the formula or in words. And then the calculating the pH here of 2.449, this whole process is worth 9 marks in total. So let's take a little look. So you'll get 3 marks for filling in, 3 marks for getting your answer, and then 3 marks for getting the pH answer. And then for the last bit, you get 3 marks for filling in, and then you get 3 marks for your final answer. So that's all the marks assigned for that question there. So let's try another exam question for you. Let's keep the ball rolling. So this next question then is 2013 question 11b, and this one focuses, rather than looking at the acid calculations, we're going to look at base calculations so that you get some experience with those. So for part B, it asks us to define a base according to Arrhenius theory and Bronsted-Lowry theory. So the key word that you're looking at there is define. So you've been asked for a definition. Then the next part asks you to give the conjugate base and conjugate acid of HPO4 2-, which should be very handy, but if you are stuck, go to examrevision.ie where you will find a full video on assigning conjugate acid base pairs, figuring them out, etc. The next part is the part that we're most interested in. It says ammonium hydroxide is produced by dissolving gaseous ammonia in water. Calculate the pH of an ammonium hydroxide solution that contains 7 grams of NH4OH per litre. The value of the base dissociation constant is 1.8 by 10 to the power minus 5. So let's take a look at this calculation part in more detail. It's worth 12 marks, so let's give it a go. Right, so let's take a read. It says calculate the pH of ammonium hydroxide solution that contains 7 grams per litre, and the value of the base dissociation constant Kb for ammonium hydroxide is 1.8 by 10 to the power minus 5. Now, I know that this is a base, so I definitely know I'm going to have to calculate pOH, which is minus log to the base 10 of the OH minus ion concentration. Furthermore, the question does ask you to calculate the pH, but instead of using minus log to the base 10 of the H plus ion concentration, we're using that already to calculate pOH. So if we remember, we learned earlier on that pH plus pOH is equal to 14. So once I calculate the value for my pOH, I will be able to fill in and rearrange to get the actual value for pH. Now, furthermore, I am also told that there's a base dissociation constant. So this means it must be a weak base. So that means the concentration of the OH minus ion is going to be equal to the square root of Kb times the molarity of your base. So there's a lot of calculation here. Now, we are going to deal with the equations in the following order. We'll start with finding the OH minus ion concentration. We'll then try and find the pOH, and the final step then is to calculate the pH. So that's them numbered. So if we look at step 1 first, we're looking at our formula here that OH minus, the concentration of it, is equal to the square root of Kb times the molarity of your base. Now, an issue for me here would be that I'm actually not told the molarity of the base. But if I check back up in the question, I can see that I am told that there is 7 grams of the ammonium hydroxide per litre. And I know if I have grams, I can convert grams to moles by dividing by the molecular mass. So that's what I'm going to do. Now you must remember, in leaving cert, you must write out your calculation to find the molecular mass in order to obtain your full marks. So I've just worked that out there, and it is 35 grams. So I need to take the number of grams that I have in the question, which is 7, and I need to divide that by 35. And when I do that, it gives me a figure of 0.2 moles per litre. So that is my value for the molarity of my base. So I can now calculate the concentration of the OH minus ion just by filling in. I know that my Kb value, it's down here already, it's 1.8 by 10 to the power minus 5, and that needs to be multiplied now by 0.2. Now, when I do that, I get an OH minus ion concentration of 1.9 by 10 to the power of minus 3. So that's my OH minus ion concentration. So that is step 1 completed. Next thing I want to do is move on to step 2. And step 2 is where we say that the pOH is equal to the minus log to the base 10 of the OH minus ion concentration. Now that's fairly handy for us because I know the concentration of the OH minus ion because I just calculated, and it worked out to be 1.9 by 10 to the power of minus 3. So you pop all that into your calculator, and what you'll get for a pOH value is you'll get a pOH of 2.72. Now, I'm not finished yet. I have one more little step to do. I have to do 3, and the formula for step 3 is where we say pH plus pOH is equal to 14. So I can rearrange that and say that the pH is equal to 14, and I can subtract the pOH. So that leaves me that my pH is going to be equal to 14, take away the pOH, which is 2.72, and that's going to give me a pH of 11.28. And at that point now, the calculation for this question is now complete. So let's just take a look at where we would be assigning the marks in this question. So there is 3 marks, first of all, for calculating the molarity of your base. There is then 3 marks for finding the concentration of the OH minus ion, 3 marks for finding the pOH is 2.72, and then 3 marks for finding the pH to be 11.28. So just to finish up, We can see from all of the exam questions that we've tried during this Saturday session today, that there is a mix of theory and calculations. Now, I skipped the theory, but I focused very heavily on the calculations, giving you 3 examples that involved strong acids, weak acids and weak bases. So you have enough of a skill set there to be able to fly any exam question that crops up based on a pH calculation. So that's it for today's Saturday session. Thanks a million for joining along. As we've stated throughout the video, our learning intention today was to complete exam questions on pH calculations, and hopefully you've been successful with that and have taken something from the video. A reminder that you can find us on our social media platforms: Twitter, Instagram, TikTok, Facebook and YouTube. And of course, the full Leaving Cert Chemistry course is available on examrevision.ie, including videos of the full course, H1 standard notes, self-correcting quizzes and exam questions and solutions. So until the next Leaving Cert Saturday session, I will see you guys soon.